Hello, this is Mrs. Nearing. In this video, I made this video to go over some of the most commonly missed problems from the solutions homework, and those are problems 14, 15, and 16. If you have questions on other problems, please let me know, send me an email, or talk to me in tutorial. So problem number 14 says we have a dioxin contaminated water source that contains 0.085 dioxin by mass, and we want to know how much dioxin there is in 2.5 liters, and we are given a density. So when you notice you're given a volume and a density, remember since density is mass over volume, then we can rearrange this. Mass equals density times volume. So if you're given a density and a volume, you can find a mass. So my volume is 2.5 liters, but my density is in milliliters. So let's convert that into milliliters. There's 1,000 milliliters per liter, and it's 1.00 gram per milliliter. So that means I have 2,500 gram sample. And the reason why I need to find a mass is because I'm given a percent by mass. So that means that of this 2,500 gram sample, 0.085% of it is dioxin. So that's 0.085 divided by 100. And when I multiply that out, I will get 2.125 grams. And then I want to look for sig figs. It looks like I have only 2 sig figs in this value, so my final answer is going to be in only 2 sig figs. So that's my final answer there. Okay, let's look at problem number 15. We're given a solution with methanol and water, and this is a little different. We're probably used to our solutions being a solid dissolved in water, but a solution could be 2 liquids combined, it could be a gas and a liquid, it could be 2 gases. Any homogeneous mixture is a solution. It could even be 2 metals. An alloy is a solution of 2 metals, a homogeneous mixture. So anyways, this is a liquid-liquid solution here. And the way that we define the solute and the solvent is the solute is the substance that there is less of. And since I have 20 mils of methanol and 100 mils of water, that means methanol is my solute and water is my solvent. And you might say, oh, well, for sure, I know water is always the solvent. But if it had been the other way around, like let's say we had been given 90 mils of methanol and 10 mils of water, in this case, water would actually be your solute and methanol would be your solvent. So it's defined by whatever there is more of is the solvent, whatever there is less of we call the solute. How many grams of methanol are in your mixture? Well, what do we know about methanol? It tells us we have 20.2 milliliters. It also tells us methanol has a density of 0.782 grams per milliliter. So if we multiply volume times density, just like we did in the previous problem, we will get 15.8 grams of methanol. And they want us to find moles of methanol. So whenever we know a mass and we know the chemical formula, CH3OH, we can use the molar mass from the periodic table, which in this case is 32.04 grams, to find the moles. This case will be 0.493 moles of methanol. So our grams canceled out, leaving us with moles. All right, let's look at problem C. How many grams of water are in your mixture? So look back up at the problem. It tells us we have 100.0 mils of water, and the density is 1 gram per mil. So my mass is 100 grams. And I want to report this to 3 sig figs, which is kind of tricky. What we can do is we can just put a decimal there, but don't put the 0 after it. So that decimal means the digits to the left of it are significant. So I've got 100 grams exactly. I want to convert that to moles. So if I have 100 grams of H2O, and I know that 1 mole of H2O weighs 18 grams. So when I plug that in my calculator, I get 5.55 moles of H2O. Okay, the molarity of the solution. Molarity is moles of solute over liter of solution. And this might seem like a really easy problem, but I imagine what's tricky about it is which moles, making sure you use the right moles and the right volume, because you're given 3 volumes and 2 mole values. So as far as moles go, we want to use 0.493, because remember we said that methanol is our solute. So I'm going to use 0.493 moles of methanol, and then liters of solution. This one might seem a little bit weird because if you look at the information you're given, they tell you that you have 20.2 mils of methanol and 100 mils of water. So you might be tempted to just add those up to get the total volume. But they also tell you the total volume of the solution is 118 mils. And that might seem odd, like those values don't add up. And that can happen sometimes when you mix liquids together. So the total volume of the solution is not necessarily going to be the sum of the individual volumes. So you just have to kind of look out for that and be careful. So the volume of the solution is 118 milliliters. So it's 0.118 liters. So if I solve to get molarity, it's 4.18 molar. Okay, percent by mass is the mass of the part over the mass of the whole thing. So the part that we are looking for is the mass of the methanol, which we found earlier weighed 15.8 grams. The mass of the whole thing needs to be the water plus the methanol. I want to add those up, multiply it by 100 to get a percentage, and that will be 13.6%. Okay, and then the mole fraction, it looks a little bit like the mass percent, except it's moles of the part over the moles of the whole. And typically we use this as we leave it in decimal form rather than converting it into a percentage typically. So methanol was 0.493 moles, and then the total moles was 5.55 plus 0.493. So you add that all up, and it's 0.0816. And notice how there's no unit there. The units moles cancel out. And again, typically we leave that in a decimal form. Okay, so that brings us to our last problem. We are looking at a solution of laundry bleach, which is sodium hypochlorite, and we're asked to find the molarity of the solution. So we want to find how many moles of sodium hypochlorite there are per liter of solution. And what we're given is we're given a mass percent and we're given a density. And I know that if I had grams of sodium hypochlorite, I could convert that into moles, right? But it doesn't seem like I have enough information to do that yet. So in a case like this where you're given a percentage, what can be really helpful, like when we did empirical formulas, remember how we said assume a 100-gram sample to kind of make your calculations easier? You can do the same thing with solutions, and let's just say assume we have a 1 liter sample. That will make our calculations a little bit easier. So we can say, well, if there's a 1 liter sample, how much would that weigh? And how much of that would be sodium hypochlorite? And then you could figure out the molarity in that 1 liter sample. And that's going to be the same. Molarity is going to be constant throughout your whole solution. So it doesn't matter which sample size you choose. You could say assume a 1 mil sample, 200 mil sample. You could pick any sample size, but you want to pick some volume to work with. So if we assume a 1 liter sample, let's convert that into milliliters, because notice our density is given in grams per milliliter, and I want to multiply that. I have a 1,000 mil sample, and a sample has a density of 1.02 grams per mil. And again, remember, where to get 1,000 mils from? I just made it up. I just picked some arbitrary volume. It doesn't matter which volume you pick. So 1 liter, if I had 1 liter, it'd be 1,000 milliliters. It would weigh 1,020 grams. So in that 1 liter sample, 4.55% of that sample would be sodium hypochlorite. So if I take 4.55% of 1,020, I will get 46.41 grams sodium hypochlorite. I want to find moles of sodium hypochlorite, so I'm going to convert that, 46.41 grams sodium hypochlorite, and 1 mole of that will weigh 74.44 grams, so that means I have 0.623 moles. And remember, what we're finding here is how many moles are in this arbitrary sample size that I chose. So in my 1 liter sample, I have 0.623 moles of sodium hypochlorite. So going back to this equation, molarity is moles of sodium hypochlorite per volume of your sample, which is 1 liter. So look at that. That was a nice, easy number to deal with. My molarity is 0.623 molar. So those are the most commonly missed questions. Please send me an email or come by tutorial if you have questions on other problems.